Rust by example, arrays and slices. With an array, we have a fixed length of data that we can provide of the same type. This is key, and this is different than a tuple, which can have a collection of different types. In an array, all the objects have to be of the same kind. So it's got to be all integers, or all characters, or all floating point numbers. They have to be all the same type. When you're dealing with a larger amount of data, an array would be more advantageous to use than a tuple due to the storing of contiguous memory. You can create an array using brackets, these bracket symbols, and a tuple is created with parentheses. Both tuples and arrays have a fixed size, a fixed length. You can't grow or shrink those arrays or tuples, which sounds kind of restrictive. If you're used to using other languages like Ruby and Python and JavaScript, you often have a capability to append, push more data into those arrays. You can't do that with Rust. There are other objects though called a vector, which gives you that ability. It's essentially an array that you can grow, and it must be of a specific type. So all integers, all chars, and so you can add elements into a vector. You can see what the current length is, and then you can remove elements from the vector. So the two foundational primitives that we are paying attention to are tuples and arrays. In this case, there is a higher level capability through vector, and so these three things, they all provide the capability to store an array of data, where a vector is going to be able to dynamically grow. In Rust, we also have a way to leverage arrays by using a slice. A slice is just, it sounds advanced and capable, and it says that it's similar to an array. However, it's just a pointer. It's just a pointer and how big that pointer is going to go. So it takes an array, any array, and it allows you to point to an element at the start and say how long you want that reference for. It's a slice. It's a slice of an array. It's like taking a slice of a pie. And if you want the whole pie, you can, your first element is 0, and then your length will be the entire length of the array, and then your slice will reference the whole pie. A slice would be often used in a string scenario where you have an array of characters sort of forming a sentence or a word. You would be able to use a slice to perhaps take substring elements of your string, of your sentence. Maybe you want to reference every single word, and so you can create a slice per word. So in this sense, slices are essentially just sort of helpers, right? They're like a little bit of like built-in tooling that we can use and leverage to make programming a little bit easier when we're dealing with a lot of arrays of data. You may not often see this in Rust, but this is how you use arrays in Rust directly. The native array will be defined by bracket symbols. The array is always going to be of a fixed size, and you cannot grow or shrink the array once it's defined, because it's all the compiler depends on this. And the compiler will help you along the way, because it will always check to see how you're using the array, whether you went too far, or mostly just if you went too far. A lot of runtime-based languages like JavaScript and Python will let you go crazy. You can definitely go beyond the scope of the length of the array that you've defined, and then you will get errors. The language will essentially crash or throw errors. With Rust, however, it doesn't do that. It won't even let you compile until you've actually fixed the problem of maybe overextending the range of your array. You can define that pretty easily by setting what kind the array is and then how long it's going to be. You don't have to do it this way either. You can define the array like this, and then the compiler will figure it out for you. Here's a quick simple example of what that looks like. We've defined our variable and our array, and then we just printed the first element. This is the way you use arrays. Now, often you'll probably see in more common Rust scenarios when you're building applications, you won't necessarily see the use of an array like this. You'll probably more likely see a vector. You'll be seeing vectors being used a lot more. This is because they're more versatile. They will allow you to append new elements to the array, and then you can also remove them. You'll probably be seeing things like this, where you've got the vec macro being defined, and you can have a size here. Downside is when you're developing a larger amount of arrays of data, you'll probably run into some performance hits. You'll just get, if you know how big the amount of data is that you're going to need, or at least you know that you can just need a large amount of arrays, you can put and pull data in and out of memory. It's better just to predefine a large array as the native type, and then you can pull data in, put that into the array, do the work that you need to do, and then bring in another chunk of data. This will be more performant. Now, a vector like this is to help when you have a large variety of use cases that you're going to reuse data in that memory area. You'll want to use a vector for this. In Rust, another way to initialize an array is to say how many elements it's going to have. You can use the bracket notation and a semicolon to be able to sort of define an array of a size, especially if you know that you're going to be dealing with a large amount of data. You'll be able to predefine that memory using this pattern here. We have a simple example where we're defining our variable, and then we're saying that it's going to have 500 elements in it. And if you want, you can also pre-fill that memory with data. It looks like that data is going to pre-fill this between 0 and 500. Oh, nope, I was wrong about that. Okay, so in this case, it looks like it's going to fill the array with zeros. So 500 zeros. What I did was I printed these two to see what the last element of the array and the first element of the array, they're both zero. Array zero. First and last element are the same, and all in between are all going to be zero. The number of elements in the array are zero. Arrays also come with a length member, or a method here that allows you to print how big that array, and just in case you forgot, I know you've defined it up here. Just in case it's actually stored within the data structure itself, it provides you a nice little method there that will give you how many elements are in that array. Now, the benefit of arrays are they are stack allocated. Now, this is going to give you the best performance possible. So when you can, and if you have the opportunity and you have the memory as well, make sure to use arrays. Comparing that with a vector where you might not need the performance, but you have an unknown amount of data that you're going to need to be processing for any given input. Use arrays if you can. Oh, this is neat. Check it out. Apparently, whenever you're using arrays and you're passing them around as a reference, you're going to be passing them as a slice. The whole array, you can pass it when you are passing it with an ampersand symbol. You're going to be using that as a slice. It will be borrowed. Reference of data as a separate piece of data in memory is going to be a reference pointer towards the array itself called a slice. And a slice is just essentially a pointer. And you can either reference the entire array itself by just providing ampersand in front of the variable. Or you could also say, oh, just pay attention to these parts of the elements. So I guess in this case, so the first position or the last position. Let's see, there we go. So we've got our YS here, which is 500 elements. It's zero. It starts with a 0, and we say that we want, so this is the entire array in that case, right? Because our YS is up here. It's 500 elements. Maybe we only care about 5 of those elements. Here we go. So just pay attention to the first 5 elements. So you can also pass this, and this will be a slice of the array. That's kind of neat. Okay, so that's how that works. I've been using this for a while, this language, and I didn't realize I've been using slices all along. Oh wait, hold on. This is an empty array? So an array of length of 0. What use is that? Maybe we're just giving a demonstration here. Interesting. Okay, so you can empty array is equal to empty array, a slice of the array. Okay, so your slicing here is also equal to a new array empty, so slice. Okay, and this is the same where you don't have any indicator. So the beginning and the end. Oh, very neat. I mean, there's not much you can do with this, but it's nice to kind of see that it's there. Mostly useless. Oh, this is, okay, here we go. So if we're gonna iterate or sort of do a loop over our array, which is very common in computer science. You always have a for loop or a while loop. In this case, we're looking at a for loop. We're going to say we've got a variable I, which is going to represent 0 to the length of XS. And then we're adding 1 just to see what that looks like from a match perspective. Oh, neat. Okay, so an array also has a method called get. And get will allow you to reference, I guess this is not much different than like this, right? So we could do it like this. Would that be the same? It's almost the same. It will give us back directly the data, the integer value in the array when we reference the data like this. However, it's going to not be returning an option, which is a container that surrounds the data. So that way we can catch whether anything was returned or not. So we can capture a none type or a sum type. So instead, we will use the built-in method for get. Okay, so we loop over each of the elements for the length of the XS value, which is going to be 5 elements. For fun, we're going to add an extra 1 here, and then we're going to check to see if there's no data that's available. Nothing was returned. And here we go. All the data is returned. Even if we attempt to go too far, the compiler lets us check for that case using this this method, and then we can code specifically for this situation. Often, for example, in business, we might have an API that has specific limits built in that's very intentional because we want to have a bounds about how we're operating on a day-to-day basis. We don't want to exceed the capacity of our purchase of the hardware. So we will build in limits intentionally. And then for these cases where we've exceeded the limit, we can let the user know that they've done this. Additionally, if we see that a lot of users want to exceed that limit, we can set the limit higher. So this is a really powerful capability that's built into Rust. It makes the code concise, clean, easy to read, but also safe. So for example, if we're going to try to go beyond, and we're going to do that without this safety guardrails, the compiler won't even let us do it. Check this out. So we'll try to run it. And it says error. We can see here that it says index out of bounds. So the compiler won't even just won't let us proceed forward. This is one of the great capabilities of, oh wait, hold on. Deny unconditional panic by okay. So if you wanted to, it looks like you could allow it to go, all right, well, I think we could, don't listen, in this case, just listen to the compiler and say that you did it wrong, and then you want to make sure to add for a check around it, probably using the get method directly, rather than it referencing the value here. And you can do this as long as you're checking for the value, but you might get a scenario where the compiler just won't let you compile. So it won't even let you build the application and push it into a production environment. Oh, just kidding. Okay, hold on a second. Out of bound indexing slice creates a runtime error. The compiler is not going to check the slice for the limitations. Oh, hold on a second. So the application will do everything it needs to do, though it's going to create a panic index out of bounds on the slice. I'm not sure how I feel. I kind of want to make sure that the compiler, it knows that it's referencing here and it knows what the limits of that array are. Why doesn't, there's got to be a reason the compiler isn't checking on this case. Either way, it does look like it makes sure not to execute this line of code because it knows that it's erroneous. And it would be nice if the compiler would check it for us. The good news is we do have a pattern here that works really well for iterating over the array using a safe and built-in pattern, and the fetching specific elements using the get method. Definitely leverage this pattern when you're accessing and iterating over arrays.